Hello friends, in this session we will consider few additional problems on calculus for aptemy test. First problem, fx is given like this. Now we have to see which statement is not true. Okay, fx is limit x tends to negative infinity. First one, fx. We can divide both numerator and denominator by x. So limit x tends to negative infinity. 2 plus 5 by x, 1 minus 2 by x. As x approaches negative infinity, 5 by x approaches 0, 2 by x also approaches 0. So it becomes 2. So this is a true statement. This is true. This is true. So this cannot be right answer because which one is false we have to find out. Next is limit x tends to 2 fx, that we have to find out. So for finding out this limit, actually let us consider this first, this one. So if x is approaching 2 from positive side, we can write x equal to 2 plus h. Okay, so I can write this is as limit x tends to 2 fx. We can write in place of 2x, we can write 2x, 2 plus 2h, 2 plus h. That means 2 times 2 plus h plus 5 divided by 2 plus h minus 2, where h here is a positive quantity. Okay, so it is what here I can write h tends to 0. So limit h tends to 0. 4 plus 5, 9 plus 2h divided by h. So it is limit h tends to 0. 9 by h plus 2. So this term, as h approaches 0, it is plus infinity. So it is becoming positive infinity, you can say. And limit x tends to 2 from negative side fx. In this case, I can write x equal to 2 minus h small quantity and positive quantity. So I can write this as limit h tends to 0, 2 into 2 minus h plus 5 divided by 2 minus h minus 2. So it is limit h tends to 0, 4 plus 5, 9 minus 2h divided by negative of h. Okay, so it is limit h tends to 0 minus negative of 9 by h plus 2. So it is basically negative infinity. So we can say limit x tends to 2 plus fx is not equal to limit x tends to 2 negative fx. So this limit does not exist. So this is actually a false statement. Okay. then limit x tends to infinity fx 2, like this. Here also it becomes 2. So if I consider this plus infinity, so it becomes again 2. So this is a true statement. So this cannot be right answer. F2 is undefined. F2 is definitely undefined. So it is a true statement. And x equal to 2 is a vertical asymptote. That means as x approaches limit x tends to 2, at x equal to 2, fx is almost infinity, undefined. Okay, and we have already seen as this is, we have seen it is positive infinity, and limit x tends to 2 negative fx is negative infinity. So at x equal to 2, the function has a vertical asymptote. So this is also true. The only false statement among A, B, C, D, E is B. Limit x tends to 2, fx is infinity, because this limit does not exist. So only statement B is not true. So answer is B. I think this is clear. Okay. Next problem. This limit x tends to infinity, divide both numerator and denominator by x to the power 4. This is the standard technique. 1 plus 3 by x square minus 1 by x to the power 4 divided by 5 minus 3 by x plus 2 by x square minus 1 by x to the power 4. So it becomes, this term becomes 0, this term becomes 0, this term becomes 0, this term becomes 0, this term becomes 0. So it becomes 1 by 5. 1 by 5 is actually 0.2. So this is the correct answer. So answer is C. Okay. Now let us consider another problem. Function fx is defined like this. Now which of the following statement is correct, or which of the following statements are correct, that we have to find out. Now f is continuous at x equal to 2. So fx is this much, fx is defined as this. Let us calculate fx, x approaches to fx. X is approaching 2 from positive side of 2. From positive side. Okay. So we can write x equal to 2 plus h, where h is a positive quantity. So I can write limit h approaching 0. In place of x, I can write 2 plus h. So, and since x is more than 2 in this case, actually, so 4 2 plus h minus 3. So it is limit h tends to 0. 8 minus 3 is 5. So 5 plus h is equal to 5. Now limit fx is, again in this case I can write x equal to 2 minus h. X is approaching 2 from negative side. So I can write x equal to 2 minus h, and h is greater than 0. So it is limit h approaching 0. x is less than 2. So I can write it's 2 minus h whole square plus 1. So it is 4 plus 1 minus 4h plus h square. So it is basically limit h approaching 0. 4 plus 1 5 minus 4h plus h square. So again it is 5. And f2, while evaluating f2 we should definitely consider the upper one, which is valid for x equal to 2 also. So it is 2 square plus 1 is 5. So this limit x tends to 2 plus fx is equal to limit x tends to 2 minus fx is equal to f2. So what we can write, fx is continuous at x equal to 2. This is correct, and this is also correct because limit x tends to 2 fx exists and its value is actually 5. Okay, now what about 2? Whether f is differentiable at x equal to 2 or not, that is to be found out. Okay, now what is the definition of f dash x? F dash x is limit h tends to 0 fx plus h minus fx divided by h. So whether this limit exists or not, let us critically examine. For that, what we do? Something like that. Let us f dash 2 is equal to limit h tends to 0 f2 plus h minus f2 divided by h. So both left hand limit and right hand limit are to be evaluated. So first calculate limit h tends to 0 from positive side f2 plus h minus f2 divided by h. Okay, now h is approaching 0 from positive side. So h you can write 0 plus some quantity delta, where delta is a positive quantity. This is a technique. Okay, delta is a positive small quantity. So I can write this thing to be equal to limit delta as h approaches 0, delta is also approaching 0. f2 plus delta minus f2 divided by delta. Now f2 plus delta means, so we are calculating what? So actually we are calculating h plus, h approaching 0 plus this much we are calculating. That means we are calculating the right hand limit, you can say, right hand limit. Okay, so 2 plus delta means we have to take this formula 4x minus 3. So limit delta approaching 0, 4, in place of x you write 2 plus delta minus 3 minus f2 is definitely 5 by delta, which is equal to limit delta approaching 0. This is 8 minus 8 plus 4 delta divided by delta. So it is basically 4 delta divided by delta, which is 4. So limit h approaching 0 plus f2 plus h minus f2 divided by h is equal to 4. Now let us calculate the left hand limit of this particular limit, which is nothing but limit h approaching 0 from negative side f2 plus h minus f2 divided by h. In this case, you take h equal to 0 minus delta, where delta is a positive quantity, positive small quantity. So I can write this thing, limit delta approaching 0. In place of h, I write negative of delta. So it is f2 minus delta, just write minus f2 divided by, in place of h you write negative of delta, so it is like this. So f2 minus delta means when the function is, argument of the function is less than 2, we use the upper one formula. So it is basically limit delta approaching 0, 2 minus delta is 2 minus delta whole square plus 1 minus f2 is 5 again divided by negative of delta. So it is 4 plus 1 minus 5, they cancel each other. So limit delta approaching 0, 4 delta minus 4 delta minus delta square. So minus negative 4 delta negative plus delta square divided by negative of delta. Okay, so here 4 plus 1 minus 5 they cancel. So minus 4 delta plus delta square divided by this thing. So it becomes actually limit delta approaching 0. It is 4 plus 4 minus delta. Again it is 4. So both right hand limit and left hand limit in respect of this limit, they are equal. Therefore, f dash 2 exists. Therefore, f is differentiable at x equal to 2 also. Therefore, 1, 2, 3 all are correct, and therefore the correct answer is E. I think this is clear. Okay, just while be careful while evaluating f dash 2. Okay. Okay. Thank you.